Okay, so this is points, lines, and planes and more. So this is section 1.1, day 1. Okay, so our learning goals is I can identify, describe, define, sketch, and symbolically name the following geometric figures. So point, line, collinear points, non-collinear points, plane, coplanar points, non-coplanar points, intersection of two lines, intersection of two planes, segment, ray, and opposite rays. So those are our goals for this section. So geometry is a branch of mathematics concerned with the properties and relationships of points, lanes, surfaces, and solids. So we have our undefined terms. These descriptions are based on Euclidean geometry. So we have a point A. So here's our point. So a point is a location in space. A point has no dimension or size. So we draw a point as a dot, so that's our point. And we always use a capital letter to name the point. Okay, so capital letter. Next we have a line. So a line is represented by a straight path that extends in two opposite directions without end and has no thickness. So we know that this is a line because these two arrows show that this line goes on forever and ever in both directions. A line is made up of infinitely many points. So on this line, we have 2 points, but there's actually tons and tons and tons of points on this whole line. So it has no thickness, made up of infinitely many points. We only need 2 points though to form a distinct line. So even though there's tons of points, we only need 2 to make a distinct line. We always draw an arrow on each end. If you don't have your arrows, it's not a line. So you will get points off. And then we name a line by any 2 points on the line or a lowercase script letter. So for our notation, we could write it as line N. So this is that lowercase script letter. Or we can use this notation, so we use any 2 capital letters that represent the points on the line, and then we draw a little line on top. So the line notation matches what a line looks like. So just another thing to note, if there are many points labeled on the line, you only need 2 points to name it. So only 2 points. Next, a plane. So a plane is represented by a flat surface, and it's made up of infinitely many points and extends without an end. So we need any 3 non-collinear points to determine a plane. So it needs to be non-collinear, okay? And then we name a plane by using at least 3 non-collinear points on the plane, or you can use the uppercase script letter. So we can call this plane H. That is the uppercase script letter right here. Or we can use notation of a plane, so it's just a little plane shape, and then we can call that plane H, or any 3 non-collinear letters, so D, G, E. Okay, so you might have heard me use the words collinear and non-collinear. So collinear points are points that lie on the same line. So an example in this picture are collinear points right there, all the points on the same line. So we have A, B, C are all collinear. Non-collinear points are points that do not lie on the same line. And we need to have at least 3 points to be non-collinear. So we could call this A, B, D. So A, B, and D are not on the same line. We could say B, C, D We could say A, C, D. As long as we have that point D in there, then we know that they're non-collinear compared to the other 2 points. Coplanar points are points that lay on the same plane. So here is our plane. So any of these points on here are coplanar points. So D, E, F, and G are coplanar. Non-coplanar points are points that do not lie on the same plane. So examples of this would be any of these points and the point H. So we need at least 4. So we know that one of the points have to be H because H is off the plane. So then we could say G, D, and F. So intersecting lines and planes. So an intersection of 2 lines is called a point. And the intersection of 2 planes is called a line. So that's our intersecting point is point X, and our intersecting line is line A. Okay, line segment. So a line segment is a part of a line that consists of 2 endpoints and all their points in between them. So in this picture we have this line AB. Line AB, remember, has the arrows on the end, goes on forever. So a segment is just these 2 endpoints and everything between it. So a segment is finite in length. Okay, so that means it has a measure, it has a distance. And then it is drawn with an endpoint on each end. And then we name a segment by its 2 endpoints. So we call this segment AB, or our notation would be segment AB with a line on top, or we could call this segment BA. Doesn't matter which endpoints the order, as long as you have the endpoints. So all of these are ways you can name a segment. So a ray is a part of a line that has 1 endpoint and extends infinitely in one direction. It is drawn with an endpoint on one end and an arrow on the other end. So we name a ray by writing the endpoint first and then any other point on that ray. And the order here does matter. So in this case, we have ray BC or ray BC with a line with an arrow on one end. So kind of how we had the line notation would be an arrow on 2 ends, a ray has an arrow on one end. And it kind of looks like the ray also. So that's how I remember the notation. Okay. Opposite rays. An opposite ray is 2 rays that share the same endpoint and extend in opposite directions. So opposite rays form a line, which is a 100-degree angle. And then we want to name opposite rays by their shared endpoint. And then any other point on each ray. So the other point doesn't matter, but what does matter is the shared endpoint. So our opposite rays in this picture would be ray KJ and ray KL. So those are our opposite rays. Okay, and that is the end of day 1.